Hey, welcome back to ICP. Today we're going to be talking about fields of engineering, specifically the different fields that you guys could be interested in. Kind of an overview, a little bit like yesterday, but getting more into the specific fields. There's aeronautical engineering. Going to work with aerodynamics, propulsion, controls, and structure. There's aerospace and astronautical engineering. This is going to deal with propulsion, cryogenics, material navigation, thermodynamics, cosmic radiation, all types of things that you wouldn't deal with necessarily in just aeronautical engineering. But there is quite a bit of overlap with the two. Agricultural engineering. You're going to deal with soil and water engineering, food engineering, power machinery engineering, structures engineering, electric power generation engineering. There's architectural engineering. There's some years I have a lot of students who want to be architects. Some years I don't have hardly very few at all. Last year I had very few architects. I think you know what architecture you're dealing with structures. Automotive engineering students always get a hoot out of looking at this little picture over here, this little backhoe. But you're going to be dealing with engine design, structural design, tire design. You could be working with motorcycles, bulldozers, tractors, trucks, automobiles. More than just automobiles. Biomedical engineering. There's a lot of engineering that goes with the simple machines into the creation of new joints. But bioengineering, medical engineering, clinical engineering, you could be dealing with a lot of things with the biomedical. Kind of goes into a lot of fields. Chemical engineering. You're dealing with chemicals, making maybe the new product that makes food cheaper. Maybe you've come up with a new chemical that allows us to make twice as much food for cows to grow twice as big, or maybe you make something that the chemical that cures cancer. Civil and construction engineering. Civil is dealing with planning and designing and supervising the construction of facilities in both the public and private sectors. For example, bridges. This is a bridge here. Bridge is civil and construction engineering. Construction can just be simply building a building or an apartment. But civil is going to be a little bit more. You're going to be dealing with bridges, highways, transit systems, dams. So civil kind of heads into a little bit more open or whatnot. I don't know how else to put it for you. Computer engineering. You could be designing the hardware, you could be designing the software. The hardware is like the computer screen. The software is the programming that it uses. Question for you: who's the largest consumer of today of computers? And that's the automotive industry. If you think about everything that goes into an automobile nowadays, and how much there's computers for your engine, there's computers for your radio, there's computers for your seats, there's computers for the thermostat, there's computer in there to run your GPS. There's just an enormous amount of computers in your automobile nowadays. Industrial engineering. Kind of skipped as I'll be back to electrical and electronic engineering here in a second. But industrial engineering is the maintenance of machinery, analysis and manufacturing, design of systems for manufacturing products, raw materials, workforce to operate machinery, and removal of finished products. Electrical and electronics engineering. They got some really old pictures here, but someone's still got to fix the old machines. Deals with the motions of electrons and metals, focus on large electrical systems, motors and generators, electrical circuits in buildings, power transmission systems, and electrical generation plants. Manufacturing engineering deals with physical plant layout, use of existing machines or new, buy or rent facilities, purchase of non-producing facilities and equipment, packaging of products, shipping to the markets. Mechanical engineering. I have a lot of mechanical engineers. Apply the principles of mechanics and energy to the design of machineries and devices, most often associated with devices that move, but includes thermal devices as well as HVAC. Vibration analysis. Why does your tire vibrate at a certain speed? That'd be a mechanical engineer or mechanical engineering. It might dive into the automobile industry, but it's still automobile engineering, but it's still going to be mechanical engineering concepts. Lubrication, gears and bearings. You'll deal a lot with gears once we get into the second engineering class. Okay, what I want you guys to do now is we just talked about, I don't know, 10, 12, 15 different fields of engineering. I want you to pick two of those, the most interesting two to you. And real quickly, give me one sentence, say, write down in one sentence what those two fields are. Maybe it's mechanical engineering and civil engineering. Or maybe you're interested in biomedical and chemical. Maybe you're someone who's interested in architecture, but I don't know. It'd be kind of cool to work with motorcycles too. So maybe you want to be automotive engineering and architectural. So pick two for right now and give me a sentence. Give me two sentences or three sentences telling me then, in addition to that first one, why you want to be involved with that, why it's cool to you, why. Maybe it's my dad does this. Maybe I really like motorcycles. Maybe I want to build houses. So, at any rate, your responsibility, pick two topics, give me 2 to 3 sentences telling me why you want those two engineering fields or why you're interested in them. That's everything for today. I'll catch you guys on the flip side.